Theivanai Ammal College for Women. Learn, live, and lead.
Hi students, I am Ravichandran, Assistant Professor of Mathematics, Theivanai College for Women, Villupuram. Now I am going to present the Cayley Hamilton Theorem. Cayley Hamilton Theorem is known as every square matrix A satisfies its characteristic equation. Cayley proved this problem by using the solution to find its inverse matrix. That is, for example, verify the Cayley Hamilton theorem for the matrix 1, 2, minus 2, minus 1, 3, 0, 0, minus 1, 1. The given matrix A equal to, we can take the matrix given matrix A equal to 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. This is characteristic equation. The characteristic equation is determinant of modulus A minus lambda I. Determinant of A minus lambda I equal to determinant of A minus lambda I. That means identity matrix, the diagonal value is only 1. So 1 minus lambda, 2 minus 2, minus 1, 3 minus lambda, 0, 0 minus 2, 1 minus lambda. Then this is matrix multiplication, 1 minus lambda into the remaining this multiplications, 3 minus lambda into 1 minus lambda, upper multiplication is minus 0, minus 2 into minus 1 minus multiply the minus 1 into 1 minus lambda. So minus 1 plus lambda minus 0, minus 2 into minus into minus 1 into minus 2 plus 2 minus 0. So next 1 minus lambda into multiply the 3 minus lambda into 1 minus lambda. We get 3 minus lambda minus lambda plus lambda squared. The remaining terms multiply the minus 2 and inner side minus plus 2 minus 2 lambda plus minus 4. So 1 minus lambda into, simplify this, add the value minus lambda in plus minus 3 lambda. So minus 4 lambda plus lambda square. So again multiply the 1 minus lambda in the quadratic equations. 3 minus 4 lambda plus lambda square, again minus lambda, minus 3 lambda plus 4 lambda square minus lambda cube minus 2 lambda minus 2. So add this higher orders first. We can write the higher orders first. So lambda cube minus, first one minus lambda cube, second the lambda squared plus 4 lambda squared. So 5 lambda squared. Remaining the coefficient of lambda minus 4, minus 3 and minus 2. So 9 lambda plus 1. So first term is a negative term. So you can multiply the minus 1. So we get lambda cube minus 5 lambda squared plus 9 lambda minus 1. This is a characteristic equation is lambda cube minus 5 lambda squared plus 9 lambda minus 1 equal to 0. Next, now we are going to verify the Cayley Hamilton theorem. If we want a square and a cube and a I, if you need the three matrices, that is after that we can verify the Cayley Hamilton theorem. Now we find the a square equal to the given matrix A into A. So A into A, the matrix form. The matrix multiplication, simply matrix multiplication, first row into first, in the first matrix first row, and the second matrix first column wise multiplication. So we get 1 into 1, 1, 2 into minus 2, minus 2, minus 2 into 0, 0. 1 into second column, we may multiply the second column, 1 into 2, 2, 2 into 3, 6, minus 2 into minus 2 into minus 2 plus 4. So first row into third column, 1 into minus 2, 2 into 0, 0, minus 2 into 1, minus 2. So second row into first column, minus 1, minus 3, 0 into 0, 0, minus 1 into 2, minus 2, 3 into 3, 9, 0 into minus 2, 0, minus 1 into the third column, minus 2. So minus 1 into minus 2 plus 2, 3 into 0, 0, 0 into 1 is 0. The third row and first column, second column, third column. 0 into 1, 0, minus 2 into minus 2 into minus 1 plus 2. 1 into 0, 0, 0 into minus plus 2, so 0, minus 2 into 3 minus 6, 1 into minus 2 minus 2. The third row into third column, we get 0 plus 0 plus 1. So finally we get to add this reduces values. Minus 1, 12, minus 4, minus 4 again, 7, and then 2, minus 8 and 1. This is A square. We found that matrix A square. Next we find the A cube, because the characteristic equation have A cube minus 5a squared plus 9 lambda plus minus 1 equal to 0. So we find the next, we find the A cube. A cube equal to A into A square. So already we found that A square is matrix. A is given matrix A into A square. We multiply the same concepts, we get the final matrix minus 13 of 42 minus 2 minus 11 9 is 10 and 10 minus 22 minus 3. This is A cube. We find A square and A cube. Next we already found the A square A square A cube. Now we substituting we find the values A square A cube in the characteristic equations. The characteristic equations is A cube minus 5a square plus 9a minus I equal to 0. So we substitute the value, we check the value is equal to 0. Minus A cube equal to minus 13, the matrix minus 42 minus 2 minus 11 9 10 10 minus 22 minus 3 minus 5 into A square. A square already found that minus 1 12 minus 4 minus 4 7 2 2 8 1 minus 8 1 plus 9 into A given matrix 1 2 minus 2 minus 1 3 0 0 minus 2 1 minus 1 into I, that is I equal to 0. I means the identity matrix, diagonal value is only 1. Next we get all the values 5 into the A square and 9 into the matrix A. We add the all elements of corresponding elements, we get the value from 0 every places. So we get the matrix is final value is equal to 0. So Cayley Hamilton theorem satisfies its own characteristic equations. Okay, thank you.